in which we have two spherical cells. So this is second case. This is first spherical cell and this is second spherical cell, and this is connected to earth. If the radius of the inner sphere is A and the radius of outer sphere is B, and charge is given to plus Q, and this will have minus Q charge. So in this case, if you want to have potential between these two surfaces, potential V will be given by Q by 4 pi epsilon naught 1 upon A minus 1 upon B. This is potential. And if you are looking for capacitance C, that will be Q by V. So C will be Q divided by V. Value of V is Q by 4 pi epsilon naught 1 upon A minus 1 upon B. So on simplification, this will be Q factor will cancel out. So we are left with 4 pi epsilon naught over 1 upon A minus 1 upon B. On simplification, it will give us 4 pi epsilon naught AB upon B minus A. So this is the formula for capacitor, which is formed by two spherical cells with radius A and B. Obviously, A is less than B. Understood? Next capacitor is most important capacitor, which is widely used, that is parallel plate capacitor. Parallel plate capacitor. Parallel plate capacitor is a capacitor in which we have two metallic plates of certain area A, and there is a separation between these two plates. Let's say separation is D. Area of this plate is A. Area is A. Certain amount of positive charge is given to plate 1 plus Q. Same amount of charge will be at plate 2, but with opposite polarity, that is minus Q. This is plate 1, this is plate 2. And we have to find out the value of capacitance C. So in parallel plate capacitor, capacitance C is given by Ka epsilon naught by D, where K is a material which is filled in between the parallel plate capacitor. So if this is a material, dielectric material like paper, wood, or any other material, then it will have value of K dielectric, and C will be given by Ka epsilon naught by D. In case of air and vacuum, in vacuum or air, we will have K is equals to 1, and in that case C will be, in place of K we will have 1, so this will be A epsilon naught by D. Next point is, if in this parallel plate capacitor we put a dielectric slab of thickness T, this is a dielectric slab of thickness T, its dielectric constant is K and its thickness is T. Overall separation between the plate is given by D. In the above case, the dielectric material is filled completely in between the plates. So there is no room for the air or vacuum. But in this case, we are having a dielectric slab in between the parallel plate capacitor, and this dielectric slab is not of thickness D, it is of small t, which means Now in this case, there will be certain region in which dielectric K will be present, and in the remaining region there will be air or vacuum. Let me call it as air. And now we want to have the value of capacitance C in this case. So the value of capacitance for this arrangement is given by C is equals to A epsilon naught or epsilon naught A upon D minus T plus T by K. So this is the formula for this case. Every information will be provided. You just have to apply the formula. Now another case in parallel plate capacitor is if this is a parallel plate capacitor with thickness D and we put different dielectric slab in between these two plates. This slab is of thickness T1 and dielectric constant K1. Then there is another slab with thickness T2, dielectric constant K2, and so on. We have nth dielectric slab with dielectric constant Kn and thickness Tn. In this case, what will be the value of capacitance C? So this is given as capacitance C in this case will be epsilon naught A divided by, since in this case we will have this formula, complete thickness is D, complete distance is D and T is the thickness. So if we are having T1, T2 dash dash Tn, in place of T it will be T1 plus T2. Let me write it as epsilon naught A upon D minus T1 plus T2 plus dash dash Tn, and along with this plus we will have next term, that is T by K. So T by K will be in this case T1 by K1 plus T2 by K2 plus dash dash dash. So on rearranging this, it will be epsilon naught A by because dielectric slabs are filling all the space between the plates, which implies T1 plus T2 plus T3 plus dash dash Tn will be equals to D. So this will be D minus D, which is 0. And finally, we are left with T1 by K1 plus T2 by K2 plus T3 by K3 plus dash dash dash. Are you getting it? Yes? Or any doubt? Okay. So next point we have how to combine the capacitors. This is known as combination of capacitors. Combination of capacitors. There are three possibilities. First one, maybe the capacitors are in series. Second, maybe in parallel combination. And third one is mixed combination, that is series and parallel both. Let's discuss first combination. If we have different capacitors in series combination, what will be the condition for that? So first point about series combination is that all the capacitors will be in one wire or will be in a single line. So there will be only one wire in which these capacitors can be connected. So the arrangement will be like this. This is the arrangement of parallel plate capacitor. Another point about parallel plate capacitor is the charge will be alternate. If this is positive, this will be negative, this will be positive, this plate negative, positive, negative, positive, negative. So charge on the plates in series combination will be alternate. So if there is no information about the wire or there is certain confusion regarding wire, we can look at the charge on the plate. If it is alternate, it will be series combination. Let's say capacitance of this capacitor is C1, for this C2, C3 and so on, and we want to have net capacitance or resultant capacitance in series combination. So the formula goes like 1 upon net capacitance in series combination, 1 upon Cs is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus dash dash dash. Now if you will take two capacitors only, special case for two capacitors, special case, let's say we have only C1 and C2. So the resultant will be 1 upon Cs equals to 1 upon C1 plus 1 upon C2, and on solving it you will get Cs equals to C1 multiply C2 upon C1 plus C2. This relation can be used directly as a formula for two capacitors in series combination. Another point about series combination is that there will be same amount of charge on the plates in series combination. So in series combination, Q will be same, but V will be different for different capacitor. So this capacitor will have potential V1, this capacitor will have potential V2 and so on. And if you are looking for the charge, if capacitor C1 has charge Q, C2 also have charge Q, C3 also have charge Q and so on. So another important point about series is that in series Q is same for all the capacitors and V is different for all the capacitors. Different capacitor will have different potential. Are you getting it? Or any doubt? Yes. Okay. बाकी के बच्चे तो मुझे लग रहा है ये बस ज्वाइन करके सो जाते होंगे आराम से. हाँ, इनका कोई रेस्पॉन्स ही नहीं आता ना. हाँ ना रिएक्ट करते, इनएक्टिव मोड में है बच्चे. नेक्स्ट कॉम्बिनेशन इज पैरेलल कॉम्बिनेशन. Parallel combination is a combination in which capacitors will be connected to a single wire, or we can say that different capacitors will be connected to a single point in the circuit. For example, let's say this is a wire and here we have a point at which different wires are emerging. One capacitor is connected to this, one capacitor is connected to this, one capacitor is connected to this, and so on. And finally, they will meet at the another one point. So this type of combination is known as parallel combination. Important point is, in case of parallel combination, each capacitor will have its different wire. So capacitor C1 have its wire separately, capacitor C2 will have its wire separately, and C3 and so on. First point is this, that in case of parallel combination, all the capacitors will have different wire and all the wires will be connected to a single point. Second point in parallel combination is that in parallel combination, potential of all the capacitors is same, but charge on all the capacitors will be different, which means charge on capacitor C1 will be Q1, charge on capacitor C2 will be Q2, and charge on capacitor C3 will be Q3. Third point, if you want to have net capacitance or resultant capacitance, in this case, this will be given by C parallel, which will be equals to C1 plus C2 plus C3 plus so on. And in case of two capacitors, we will have Cp is equals to C1 plus C2. Interesting point is that results on capacitor are opposite of the results in resistor. If we are having two resistors in series, then RS is given by R1 plus R2. And this result is taken in capacitor in parallel. C parallel is C1 plus C2. So results on combination of resistor and combination of capacitors are opposite to each other. Next point is about mixed combination, which is basically a combination of series and parallel. And in that case, we do not have a specific formula. We will just simplify it by doing calculation for parallel combination separately and series combination separately. Okay, next, let's say let us take a simple result on this. For example, we have a capacitor of 2 microfarad which is connected in series with another capacitor of 3 microfarad, and we want to know what will be the resultant capacitance. So in series, resultant capacitance is given by for two capacitors C1 into C2 by C1 plus C2. So what will be the answer? This will be 2 plus 3, sorry, 2 into 3, 6. Let me write it as 2 into 3 divided by 2 plus 3. So this will be 6 divided by 5 microfarad. Next, if we have these two capacitors in parallel combination, let's say this one and this one. This is 2 microfarad. This is 4 microfarad. What will be the resultant? So this will be C parallel, which is given by simply C1 plus C2. So this will be 2 plus 4, that is 6 microfarad. Next is if we are having combination of both the cases, something like this. This is arrangement. In this arrangement, all the capacitors are of 1 farad or 1 microfarad. 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad, and 1 microfarad. So in this case, we have some capacitors in series and some capacitors in parallel. All these capacitors are in parallel because they are emerging from one single point and they are again connecting to the one single point. So they will be in parallel. And in parallel combination, we have resultant Cp, which is given by C1 plus C2 plus C3, which will be, I think, 1 plus 1 plus 1, that is 3 microfarad. So new arrangement of the capacitors will be like this: 1 microfarad, 1 microfarad. Then we have combination of all the three capacitor, that is 3 microfarad, and then again 1 microfarad. So this will be 1 microfarad, 1 microfarad, 3 microfarad, and 1 microfarad. What will be the resultant in this case? So we will write it as 1 upon Cs is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon C4. And the values will be 1 upon 1 will be 1, 1 upon 1 will be 1, 1 upon 3 will be there, and 1 upon 1 will be 1. So 1 upon Cs will be 3 plus 1 upon 3. That is 3, 3 is the 9 plus 1, 10 by 3. And if you will reciprocate it, you will have Cs, that will be 3 by 10. That is 0.3 microfarad. Understood or any doubt?
Sir, is this necessary to solve this parallel combination first?
Yes, and then we will deal with series combination. It is not necessary that you just have to solve parallel first. You can also look it in this way. Let us consider this pair alone, this pair separately, this one separately, and this one separately. So we can solve these two separately by series combination, which will give, I think, 2 microfarad. and then this one will give 3 microfarad and this one is separately 1 microfarad. So this can also be taken as 2 microfarad, 3 microfarad and 1 microfarad. So there may be different ways to look at it.
Okay, sir.
Next point is about, which is again very important concept, and this is known as potential energy stored in a capacitor. Potential energy stored in a capacitor. So potential energy stored in a capacitor is given by potential energy U is equals to 1 by 2 Q into V is equals to 1 by 2 CV square is equals to 1 by 2 Q square C. Out of these, you just have to remember one formula, and remaining formulae can be managed because we know the relation between C is equals to Q upon V. So if you will remember the first formula, U equals to 1 by 2 Q into V, and in place of Q you can have CV, so this will be CV square, and in place of V you can have Q by C, so we will get this formula. So you just have to memorize only one part of it. Any one of the formula will work. Understood? Again, here question will be straightforward. Like we have find the potential energy of a capacitor having charge, having 2 coulomb charge at 4 volt potential. So in this case, we have the value of Q, potential V is, and we have to find out potential energy U, which will be 1 by 2 into QV. We have this formula 1 by 2 into QV. So we can apply it. This will be 1 by 2 into 2 into 4. So potential energy U will be 4 joule. Understood? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
One last formula is energy density. Energy density between the plates. Energy density between the plates will be given by energy density U is equals to overall energy divided by volume, and this will be 1 by 2 epsilon naught E square, which means if we know the magnitude of electric field, we can know the energy density. For example, let's say we have to check how, let me write it as find the energy density in the electric field of strength 10 Newton per coulomb. So energy density U is 1 by 2 epsilon naught E square. So this will be 1 by 2 into epsilon naught into E square will be 10 square. So this will be 100 by 2, that is 50 epsilon naught. So this will be the energy density. And unit for energy density will be joule per meter cube. Understood?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes. Any doubt?
No, sir.
Okay. So last case is redistribution of charge. Redistribution of charge. In this concept, we have two conductors or two capacitors, and these two capacitors will be connected with a wire, conducting wire. But before that, before the connection of wire between these two capacitors or conductors, we have certain information about them. This is conductor 1 with capacitance C1. This is conductor 2 with capacitance C2. Charge on conductor 1 is Q1. Charge on conductor 2 is Q2. Potential of the conductor 1 is V1 and potential of the conductor 2 is V2. This is the condition before connecting them using a wire. Now let's say we connect them using a wire, and as the wire will be connected to both the conductors, there will be charge flow from one conductor to another conductor because of potential difference, because we are having two conductors at different potential V1 and V2, and we do not know which potential will be greater and smaller. So the core point is that there will be certain potential difference between the conductors, and due to that potential difference, charge will flow from one conductor to another conductor. Which charge will flow, that will also depend on the conductor, which type of charge they are accumulating. So let's say charge flow from one conductor to another conductor, and in that case there will be a common potential when there will be no flow of charge. So you have to calculate that common potential V. What will be the common potential of the these two connected conductors or capacitors? So common potential is given by V equals to because general formula for C is Q by V. So V will be given by Q by C. And using this formula Q by C, we can give common potential. Common potential will be overall charge Q1 plus Q2 upon overall potential C1 plus C2. And now again using the same formula, we have Q is equals to C into V. So common potential V can be written as, in place of Q1 we can have C1 V1 plus C2 V2 divided by C1 plus C2. Then we have energy loss that is given by delta E, which will be equals to 1 by 2 C1 C2 into V1 minus V2 whole square, that is difference square of the potential difference, divided by C1 plus C2. So these two formulae will be used. Understood or any doubt? ओके
सर ये फॉर्मूला कहाँ से आया?
ये डेरिवेशन करना पड़ेगा सर, डेरिवेशन से मिलता है.
ओके सर.
अब ये कंप्लीट कर सकते हैं आप. इलेक्ट्रोस्टैटिक्स इज कंप्लीटेड. नेक्स्ट वी हैव केमिस्ट्री.
सर इसके प्रैक्टिस क्वेश्चन कब मिलेंगे?
आज मिल जाएंगे. कंप्लीट हो गया, सब क्लब करके है ना, तो आज मिल जाएंगे इसके. ठीक है.
ओके सर.
In chemistry we have done redox reaction, right?
Yes, sir.
So now we can start with another topic. Atomic structure. Atomic structure of an atom gives us information about the composition of the atom. How an atom is formed. The theory goes like this: anything which occupies space and have mass is known as matter. And matter is made up of some small particles known as atoms. Initially, it was considered that atoms are indivisible and we cannot further divide them. But after the experiments, it came into light that atom is not indivisible, it is divisible. It can be further divided into subatomic particles. And these subatomic particles are known as what? Electron, proton, and neutron. So matter is made up of atom, which is not the smallest unit. In fact, atom is made up of subatomic particles, and these subatomic particles are electron, proton, and neutron. Subatomic particles. So we have three subatomic particles. Basically, we have more than three, but there are only three in which we are interested. So we have three subatomic particles. Electron is one of them, proton and neutron. Basic information about electron, proton, and neutron you must have. What is the mass of electron? That is 9.1 into 10 raised to minus 31 kg. What is charge on electron? That is minus E. What is the mass of proton? Mass of proton is 1.673 into 10 raised to power minus 27 kg. What is charge on electron? Charge on proton, that is plus E. Now, mass of the neutron. What is the mass of neutron? Mass of neutron is 1.675 into 10 raised to power minus 27, and charge on neutron is 0. So these are the basic information about subatomic particles in an atom: electron, proton, and neutron. From these information, you can conclude that mass of proton is approximately same as mass of neutron, and it is way bigger than mass of electron. If you will compare the mass of electron and proton, you will notice that mass of proton will be approximate 1,000 times greater than mass of electron, which means proton and neutrons are far more heavier than electrons. That is the reason in atomic mass only protons and neutrons are considered, and the mass of electron can be neglected. Or in other words, we are stating that mass of an atom is calculated by taking into account protons and neutrons only, not electrons. Because mass of electron is very less, it can be neglected. Understood? Next, it may be like who discovered who. So we remember it as eat per notch. E for electron, T for Thomson. Electron was discovered by Thomson. P for proton, R for Rutherford. Proton was discovered by Rutherford. N for neutron, CH for Chadwick. So neutron was discovered by Chadwick. And then they were defined by Thomson, Rutherford, and Chadwick on the basis of their properties. What are the properties for electron? It has negative charge, its mass is something finite value, and if you will pass a stream of electron into electric field, electron will go towards the positive blade, which indicates that they will have negative charge. And if they are passed through magnetic field, they will deviate from their path, which indicates that they have certain amount of charge. Any doubt in it? Yes, any doubt in
No,
it?
sir.
Okay. Next point will be atomic models. So to understand the structure of atom, how electrons, protons, and neutrons are arranged inside an atom, or how electrons, protons, or neutrons reside inside an atom, we have different theories for that, which are known as atomic model. Atomic models. So we have different atomic models at different timeline in history. First one is, which was the first one? It was J.J. Thomson's atomic model. J.J. Thomson's atomic model. After J.J. Thomson's atomic model, we have Rutherford's atomic model. Rutherford's atomic model. After Rutherford's atomic model, we have Bohr's atomic model. After Bohr's atomic model, we have Sommerfeld's atomic model. And finally, we have, which is known as quantum atomic model or latest atomic model. So these are the models. First one is J.J. Thomson's atomic model. What are the key points in J.J. Thomson's atomic model? In J.J. Thomson's atomic model is considered to be a sphere, and J.J. Thomson told that all the positive charge is uniformly distributed, and in that positive charge, electrons are embedded inside the positive charge like seeds in watermelon. In watermelon, reddish part is the positive part or proton, and seeds will be working as electrons. So this is how J.J. Thomson's atomic models look like. The key point is uniform distribution of positive charge, non-uniform distribution of electrons, and spherical in shape. These are the key points in J.J. Thomson's atomic model. J.J. Thomson's atomic model is also known as plum pudding model. Plum pudding model. And there are certain drawbacks to it. The most important drawback is this atomic model cannot explain the stability of atom, and it cannot explain the results obtained from Rutherford's experiment. Rutherford did an experiment which is known as alpha scattering experiment, and on the basis of results from alpha scattering experiment, he designed a new model which is known as Rutherford's atomic model or planetary atomic model. What are the key points in Rutherford's atomic model? In alpha scattering experiment, he discovered that there is a central part of an atom or of any atom which is solid, rigid, and dense. And this part is now known as nucleus of the atom. Nucleus of the atom. And this nucleus is positively charged, which means all the protons resides inside the nucleus. And other part is empty, and electrons revolve in that part in circular orbits. So Rutherford's atomic model is somewhat like planetary model in solar system, in which there will be sun at the center, same as nucleus, and there will be circular orbits around the sun, same will be in atom, and electrons will revolve around the nucleus, same as planets revolve around the sun. So due to its analogy with solar system, it is also known as planetary model. Understood? So the important point about Rutherford's atomic model is that Rutherford discovered nucleus and proton. First point. Second point, all the protons reside into the nucleus and it is solid, rigid and dense. And the other part of the atom is almost empty. There are circular orbit and electron revolving in that orbits. Now, what are the drawbacks for Rutherford's atomic model? The main drawback of Rutherford's atomic model is that it cannot explain the stability of atom. According to this model, electrons revolve in circular orbit, and electromagnetic theory states that if any charge is continuously accelerated, it will radiate its energy. And if it is so, electron will also radiate its energy, and the circular path of the electron will become smaller and smaller, and finally it will be into the nucleus. It will jump into the nucleus. And if it happens, the atom will be destroyed or atom will not exist. So it cannot explain stability of the atom. Another drawback of Rutherford's atomic model is that this model cannot explain the distribution of electrons. Distribution of electrons means it cannot explain how many electrons should be in first cell, how many electrons will be in second cell. This model cannot explain the electronic arrangement around the nucleus. So again, we need another model which is known as
हेलो
Bohr's
सर.
atomic model. Yes,
सर आप ये अचीवमेंट और ड्रॉबैक आप लिख नहीं सकते क्या इस नोट्स में?
ड्रॉबैक लिखूं?
सर आप लिख दोगे तो बाद में रिवीजन करने में इजी होगा.
Okay, first drawback is cannot explain stability. And second drawback is cannot explain arrangement of electrons around the nucleus. Cannot explain stability. Understood?
यस सर.
Next model is Bohr's atomic model. Bohr's atomic model is basically a updated version of Rutherford's atomic model. Bohr took Rutherford's atomic model and he limited the limitations which were present in Rutherford's atomic model. How did he do it? He postulated some concepts to explain the stability of atomic model, which is not true in the case of Rutherford's atomic model. So he postulated some concepts which are known as postulates of Bohr's atomic model. The first postulate is electrons revolve around the nucleus in stationary orbits. Stationary orbits or fixed energy levels. Fixed energy levels. What is it? This postulate states that if electron is revolving in a circular orbit around the nucleus, its overall energy will be constant, which means it will not either absorb energy or radiation, or it will not radiate the radiation. So if there is an electron which is revolving in cell number first, its overall energy will be constant, and this amount of energy cannot be changed by itself. So electrons revolve in stationary orbit or fixed energy levels. These fixed energy levels are known as stationary orbit or quantized energy level or fixed energy level. This is first postulate. Second postulate in Bohr's atomic model is that if an electron jumps from one cell to another cell, it cannot be done by the electron by itself. If electron is going from one energy level to another energy level, certain amount of energy must be given to the electron, and then electron will move from low energy level to higher energy level, and in higher energy level it will remain for some time, and after some time it will again come back to its lower energy level. So in this process, whenever electron is going from one energy level to another energy level, there will be obviously some energy difference which has to be provided to the electron. So this energy is given by delta E, which is E final minus E initial, which is given by h nu or hc by lambda, which means if we are giving certain radiation of a frequency to the electron, it will go from one energy level to another energy level, and when it will come back, it will emit the radiation with same frequency. This is second postulate. Third postulate is how will an electron select its orbit? So it means if we are having an electron, how will we decide that whether this electron will go in cell number 1 or cell number 2 or cell number 3? So this will depend on the velocity of the electron, speed of the electron, and there is a concept which will decide whether the electron will go in whichever cell. The postulate is any electron can reside or can be in any particular circular orbit if and only if its angular momentum of electron is integral multiple of h upon 2 pi. That is, it has to be n into h upon 2 pi, and angular momentum of electron is given by mass of the electron into speed of the electron into radius of the circular orbit r is equals to n h upon 2 pi. Now if you will look at the value of n, you will have mvr into 2 pi divided by h. N has to be an integer. So to make n an integer, r has to be arranged in such a way that n will give an integral value. Or you can also look it in different way. For example, r will be nh upon 2 pi into mv. So if we have mass of the electron, velocity of the electron, Planck's constant and 2 pi, then r have a definite value according to n. If n is 1, r will have h upon 2 pi into mv, and if n is 2, it will have h upon pi into mv. So the value of r is connected with value of n, which states that energy levels in an atom are quantized, which means circular orbits will be at finite distance around the nucleus. In other words, it implies that circular orbit in space cannot be anywhere. It has to be at a specific distance. Are you getting it? Yes or no?
Yes, sir.
आसान भाषा में इसका मतलब यह है जैसे अर्थ है, अर्थ सन के चारों तरफ जब रिवॉल्व करता है तो अर्थ रैंडमली किसी भी डिस्टेंस पर नहीं है. अर्थ का सन से एक फिक्स डिस्टेंस है और वो डिस्टेंस कभी चेंज नहीं होने वाला, वो हमेशा इतना ही रहेगा. So orbits has to be quantized. They will be at a finite and fixed distance, and that distance cannot be changed. Understood? Now there are again certain drawbacks in Bohr's atomic model also. And the drawbacks in Bohr's atomic model are, first one, this atomic model cannot explain splitting in hydrogen spectrum, or in other words, we call it a Zeeman effect and Stark effect. So Bohr's atomic model cannot explain before that, in Rutherford's we have one more drawback. Let me write it as here. It cannot explain hydrogen spectrum. Rutherford's model cannot explain hydrogen spectrum, which is a plus point for Bohr's atomic model. Bohr's atomic model can explain hydrogen spectrum. It can explain hydrogen spectrum. But Bohr's atomic model is not capable to explain why lines in hydrogen spectrum gets splitted if they are placed in magnetic field or electric field, which is known as Zeeman effect and Stark effect. And another drawback for Bohr's atomic model is it cannot explain spectrum of other atoms. Spectrum of other atoms than hydrogen. So it can explain only and only hydrogen atom. It cannot explain the spectrum of any other atom. Or it can explain only spectrum of those atoms or ions which are same as hydrogen or which have same electronic structure as hydrogen. Again, it cannot explain splitting of spectral lines in magnetic field and electric field. Cannot explain splitting of spectral lines. If a spectral line is in magnetic field and gets splitted, this is known as Zeeman effect. Zeeman effect. Splitting of spectral line in magnetic field is Zeeman effect. And if spectral line gets splitted in electric field, then this is known as Stark effect. Stark effect. Understood or any doubt? Yes.
सर जे थॉमसन का बस एक ही ड्रॉबैक था।
क्या?
जे थॉमसन का बस एक ही ड्रॉबैक था।
जो बोर्स के ड्रॉबैक है या जो रदरफोर्ड के ड्रॉबैक है वो भी जे थॉमसन के ड्रॉबैक होंगे, बिकॉज जे थॉमसन का जो एटॉमिक मॉडल है इट इज द स्टार्टिंग मॉडल, so it cannot explain all these things. It cannot explain hydrogen spectrum, it cannot explain any spectrum of any other atom, it cannot explain the splitting of spectral lines, right? So all the drawbacks for Rutherford and Bohr's atomic model are also the drawbacks for J.J. Thomson's atomic model. Understood? Yes or no?
यस सर।
Okay. Now next we have the most important model, that is quantum model. In quantum model, an atom is taken as a building. In building we have floor. In atom we have cells. On floor we have flat. In cells we have subcells. And in flat we have room. Similarly, in subcell we have orbitals. In room there will be persons, and in orbitals there will be electrons. So this is the analogy between living of a person to the living of an electron. As person lives in room, similarly electrons lives in orbital. So quantum atomic model explain all these things: cell, subcell, and orbitals. Let's start with cell. Cells, then we have subcells, then we have orbitals. For subcell, we represent N. For subcell, we take L. For orbitals, we take M. N is known as principal quantum number. N is known as principal quantum number. What is L? L is known as secondary quantum number. Secondary quantum number or azimuthal quantum number. Azimuthal quantum number. Then we have M, which is known as magnetic quantum number. Magnetic quantum number. Principal quantum number N explains about, it gives us information about cell, size of subcell, cell, size of subcell, and size of orbital. Secondary quantum number or azimuthal quantum number gives us information about subcell. Which type of subcell we are taking? S subcell or P subcell or D subcell or F subcell. So this will help us to select subcell inside a cell. And magnetic quantum number is about orientation of the subcell. And hence orbital. So quantum number are address of an electron. Same as we have address as a person, same electron has an address which is given by N, L, and M. We have 4 quantum numbers: principal quantum number, secondary and magnetic. Last one is spin quantum number. Spin quantum number, which is given by S. And its working is to tell us about rotation of the electron, in which direction electron is rotating. Rotation of electron. It either may be anti-clockwise or may be clockwise. Anti-clockwise or clockwise. In case of anti-clockwise, we will take upward. In case of clockwise, we will take downward. And for anti-clockwise, let's say we have plus 1 by 2. And for clockwise, we have minus 1 by 2. Understood or any doubt? Yes? Any doubt in it?
No, sir. Clear.
Okay. Let's see how it works. For example, we have three p5 and we have to get all the information about fourth electron in 3p5. So in this case, n will be 3. Remember, L has fixed value. L is not going to change. L will be either 0, 1, 2 or 3. L will be 0 if we are having S subcell. L will be 1 if we are having P subcell. S will be 2. L will be 2 if we are having D subcell. And it will be 3 for F subcell. So in this case, the value of n is 3. This is principal quantum number n. And in this case, what will be the value of L? Because we are having P subcell. So value of L will be 1. If we have L as 1, we can find out the value of M, which is given by minus L2 plus L. So M will be equals to minus 1, 2 plus 1. That will be minus 1, 0 and plus 1. So M has three different values, which indicates that P subcell has three orbitals. So three different values of M indicates that P subcell has three orbitals. So these are the three orbitals of P subcell, and electrons will be filled in these three orbitals. We are having total 5 electrons. So this will be 1 electron, 2 electron, 3 electron, 4 electron and 5 electron. According to question, we are interested in fourth electron. So which will be fourth electron? This one. This is fourth electron. So fourth electron in which orbital? This is minus 1, 0 and plus 1. So for fourth electron, value of M is minus 1. And value of S, because it is downward, so this will be minus 1 by 2. This is the way to calculate quantum number for an electron. Understood or any doubt? Let's do one more question. Find all the quantum numbers for fourth electron in 3D7. So in this case, we have 3D7. What will be the value of N? N will be 3. This is N. What will be the value of L? For D, the value of L is 2. So this will be 2. What will be the values of M? This will be minus L2 plus L. So it will be from minus 2 to plus 2, which will give us minus 2 comma minus 1 comma 0 comma plus 1 comma plus 2. So there are total 5 different values of M. Since there are total 5 different values of M, it indicates that there will be 5 orbitals in D subset. So D subset has 5 orbitals, 1, 2, 3, 4 and 5. Now we have to fill 7 electrons. So this will be 1, 2, 3, 4, 5, 6 and 7. So this one is the 7th electron. And if you will arrange the values for m, this will be -2, -1, 0, +1, +2. So for we have to calculate information about 4th electron. Sorry, it's not the 4th electron. So we have to take 4th electron. First, second, third and fourth. This is 4th electron. So for 4th electron, what will be the value of m? This will be +1. And what will be the value of s? This will be +1/2 because it is upward arrow. Understood? Understood? Okay. मैथ्स निकाल लेंगे. स्टार्ट करें भाई. In maths we have completed determinant, right? Next topic we are going to discuss is sets and relation. So first let us discuss about sets. What is a set? Yes. What is a set? Set is a collection of well-defined objects. Collection of well-defined objects. Any set will have certain objects. These objects may be functions or numbers or any variable or any information. All these objects are known as elements of the set. Elements of the set. Elements आवाज आ रही है भाई?
Yes, sir.
Methods to describe a set. पता नहीं, याद नहीं है ये, इधर से करना पड़ेगा. Methods to describe a set. First one is roster form, or this is also known as listing method, or tabular form. Second one is property method, or rule method, or set builder form. In the first form, individual element has to be listed. Individual element has to be listed, has to be mentioned. While in the second method, we only use common property of all the elements. For example, we have vowels in English alphabet. Which is given by A, E, I, O, U. Now this information or these objects can be represented into two different forms. First form is tabular form, in which we will represent the set using a capital letter V or any other letter X, Y, Z. We will put curly bracket and all the vowels will be listed or will be mentioned into the bracket individually. So it will be A, E, I, O, U. Or second method may be in which we will not write down the individual letter. We can just tell about the common property they have. So all these letters or alphabets have common property that they are vowels. So we can write it as set V contains an arbitrary element X such that X is a vowel of English alphabet. So this set will also give us the same information as the set number 1. In this case, we will take an alphabet and we will look at its property, whether it is vowel or not. If it is vowel, we will put it into the set, and if it's not, we will exclude it. Understood? So there are two methods for it. Now, in this set, element A is in set V, or element A contains, element is in set V, or element A belongs to set V, or V contains element A. All these phrases can be given by mathematical symbolical V does not contain these phrases can be represented as B does not belong to set V. So if there is an element in the set, we write it as belongs to, and if it's not in the set, we write it as does not belongs to. Understood? For example, we have a set A, which is 1, 2, A, B. So we can write that 1 belongs to A, 2 belongs to A belongs to A, and B also belongs to set A. On the other hand, 3 is not in set A, so 3 does not belong to set A. 4 is not in set A, 4 does not belong to set A, 0 is not in it, so 0 does not belong to set A. C does not belong to set A. Understood? Understood? Okay, next point is types of sets. First set is which is known as empty set or void set. This is given by phi or open curly bracket. You have to put nothing into the bracket, not even dot. If you will put dot, this will be wrong. So you have to just write simple square bracket. Sorry, curly bracket. Or you can use this symbolical representation to represent a empty set or void set. Empty set or void set is a set which has no element. Second point is, okay, this is also known as null set. Second is singleton set. Singleton set is a set which contains one and only one element. One and only one element. One and only one element. For example, we have set A contains one, or we have set B. Set B is what? Let's say this is E. So these all are singleton set. Third is finite set and infinite set. Finite set and infinite set. This classification is done on the basis of number of elements present in a set, which is known as cardinal number. Cardinal number or cardinality, which is given by number of elements present in any set. For example, if we have a set V which contains A, E, I, O, U, then its cardinality will be cardinality of V is same as cardinal number of V is same as NV. NV means number of elements present in set V. So there are total 5 elements. So its cardinal number will be 5. Understood? Now we can define finite and infinite set. Finite set, infinite set. Finite set will be if number of elements are finite, or in other words, countable. You can count them. On the other hand, infinite set will be a set in which number of elements are infinite or uncountable. For example, if I have set A x such that x is even prime. X is even prime number. What will be the value for set A? Yes, even prime number. Anyone?
There's singleton set. Only two.
Which one?
The element is only two.
Which is the even prime number?
Two.
2. So set A will have only and only one element, that is 2. Which means set A is singleton set. And its cardinal number is 2, which is finite. So this is finite set. If I write another set B, which is as Z such that Z is even number. Z is even natural number. So what will be set B? Set B will be like 2, 4, 6, 8, and so on. Yes or no? So this will be the example for infinite set. Understood? Next we have, after finite and infinite, we have equivalent set. Equivalent sets. Two sets A and B are said to be equivalent if and only if their cardinal number is same. So NA is equals to NB. In that case, set will be equivalent. For example, we have set V A, E, I, O, U, and we have another set A, which is 1, 2, 3, 4, and 5. You will notice that cardinal number of set V is 5. Cardinal number of set A is also 5. This implies that V and A are equivalent set. Are you getting it? Next type of set is equal sets. और ये तो 12th का है भी नहीं, ये तो 11th का है. सेट थ्योरी सिंपल सा कॉन्सेप्ट है. अगर ध्यान से सुनेंगे तो समझेगा ये भी आराम से. और मैं तो ये भी नहीं बोल रहा कि ये पढ़ो तुम. मैं ये बोल रहा हूँ ये नहीं पढ़ना, नहीं समझता, फास्ट जा रहा है, अपना बैठ के चुपचाप से काम कर लो. बात करते रहेंगे, टाइम बेकार करेंगे नालायक. Equal sets. Let's say we have two sets A and B. These two sets A and B are equal if and only if first their cardinal number is same, and second each element has to be exactly same. Each element same, or in simple words, if two sets have exactly same element, then they are said to be equal sets. For example, set A is X such that X is a vowel of English alphabet, and set V is A, E, I, O, U. So we know that set A and set V will have exactly same element in number and in its property. So we can say that set A is equals to set V. If two sets are not equal, if two sets A and B, let's say, are not equal, then we will write it as A is not equals to B. Understood? Next concept in set theory we have, which is very important concept, subset and superset. So what is the concept of subset? Let's say we have a set A in which we have element 1, 2, and we have another set B which has 1, 2, A, B, C. So you will notice that all the elements of set A is in set B. So in this case, we say that A is a subset of B and B is superset of A. Another point is that set A is contained in set B and set A is not equals to set B, which implies that A is proper subset of B. So the condition for proper subset is that in set B there has to be at least one element which is not in set is present in any other set, then the first set is subset of the second set. For example, if I have, let's say, set V, which is A, E, I, O, U, and there is another set Z, which is X such that X is English alphabet. English alphabet. So in set Z, we present in set Z, which means V is a subset of Z, and Z is a power set of, sorry, Z is a superset of V. Again, we can also state that V is a subset of Z and V is not equals to Z, which implies that V is a proper subset of Z. So this is the condition of set, subset, proper subset, and superset. Yes? Any doubt? Certain important theorems regarding subset. First point is empty set is a subset of, empty set is a subset of every set. Is a set itself. Each set is a subset of itself. Third important point is each set is a superset of itself. Each set is a superset of itself. Next point is, if you want to find out number of subset of any set, so number of subsets of any set is given by 2 raised to power cardinal number of the set. And if you want to have number of proper subsets, number of proper subsets, in that case, total number of subsets will be 2 raised to power 1, 2 raised to power n and minus 1. Because in these subsets, one subset is improper subset. So we have to subtract improper subset out of total subsets, and hence we will get number of proper subsets. Proper subsets. For example, let's say we have a set B which have A comma B 2 elements. So cardinal number of set B is 2. So we can find out total number of subset of set B. So number of subsets of set B is given by 2 raised to power 2. Hello. Lecture में बातें मत करें. So total number of subsets will be 2 raised to power 2, that is 4. Now how to write these subsets? So for set B, we will write all the subsets. So first subset is 5 because 5 is subset of every set. Second subset is set itself, A comma B itself is a subset of set B. And then we will have curly bracket A and curly bracket B. So these are the total 4 subsets. In these 4 subsets, this subset is known as improper subset. This is improper subset. And rest of them are proper subset. Rest of them are proper subset. Proper subset. So improper subset is 1. Improper subset is 1 and it will be 1 in all the cases. So proper subset are left with proper subset are total subset minus improper. There will be 3 proper subsets. Understood? So if we have a set B with cardinal number 4, then find number 1, number of all subsets. Number 2, number of proper subset. Number 3, number of improper subsets. So this will be what? If NB is how much? 4. So number of subset will be what? Number of all the subsets will be 2 raised to power 4. That is how much? 16. Second, number of proper subset will be how much? 16 minus 1, that is 15. And number of improper subset will be what? Number of improper subsets will be 1. Are you getting it? Yes, any doubt in it? Any doubt? Okay.
No, sir.
Next is write down all the subsets. Write down all the subsets of set A, which is given by A comma B comma C. So total subset will be how much? total subsets will be 2 raised to power 3, that is 8. And now we will write them. So first will be 5, then set itself a comma b comma c, then take individual element, curly bracket a, curly bracket b, curly bracket c, then take the pairs. This will be a comma b, b comma c, and a comma c. We cannot have a comma b, b comma a, because a comma b, b comma a will be same set. So there are total 8 subsets. Understood? Next is intervals. If we have x such that x is in between a to b, including endpoints a and b, so we write it as x belongs to interval a comma b with square bracket. Square bracket here indicates that point A and point B is also included. On number line, this will be represented as this is point A, this is point B. Point A and point B are included, so we will put dark. And all the elements between A and B, so this will be the resultant. This is known as closed interval. Second one is open interval, that will be A is in between, x is in between A to B, excluding endpoints A and B. In this case, we write it as x belongs to open interval A comma B. And on number line, this will be given as A, B, here will be open, here will be open, and all the elements between them are taken. This is known as open interval. Open interval. Next we have semi-closed, semi-open. So this will be like x is in between A and B and A is included. So we will write it as x belongs to closed interval A comma B open interval. And if it is x in between A to B including B, we will write it as x belongs to open interval A and close interval B. Understood? Understood or any doubt? Okay. Next point we have Venn diagram. But before that, we have to discuss power set. I just skipped it. What is a power set? Anyone? What is a power set? Power set is the set of subsets of any set. So if we have a set A, first of all, we will write subsets of set A, and then we will make a new set of subsets. Then this new set of subsets is known as power set. For example, if we have set A as A comma B, first we will write subsets. Write all the subsets. Subsets are 5, curly bracket A comma B, curly bracket A, and curly bracket B. These are the subsets. Now make a new set of these. So to make a new set, these will work as elements or objects. So we will take a curly bracket, and in that we will put all the subsets. That is 5, curly bracket A comma B, curly bracket A, curly bracket B. So this will be the new set of subsets. and this new set of subset is known as power set of A. We will write it as this, power set of A. Important point about power set is that if you want to have number of elements in power set, so this will be equals to number of elements in power set will be equals to number of subsets. That will be equals to 2 raised to power cardinal number. Understood or any doubt?
Good, sir.
Next point is Venn diagram. Venn diagram is a pictorial representation of any set. So there will be a largest set regarding any problem in set theory, which is known as universal set. And there will be other sets which will be subset for universal set. Let's say A is a subset of universal set, or let me write it as proper subset. So we will pictorially represent it as, this is universal set U and it contains a set A. This is set A. This is the concept of Venn diagram. In Venn diagram, we represent the set by a figure. It may be triangular, it may be circle, it may be square or rectangle. Understood? Next point is operations on sets. Okay, we will do it in next lecture. अभी जनरल एप्टीट्यूड करा देता हूँ. यहाँ तक कोई डाउट है सेट थियरी में?
No, sir.
No, sir.
General aptitude. Okay, after time and distance, we will do a related concept, which is boats and streams. Point number 1, if any object is going along with the stream, we call it as downstream. So if uh, flow of water is in this direction, and object is also moving in the same direction, then we call it as downstream. And if object is going against it, we call it as upstream. Understood the meaning of downstream and upstream? If boat is going along with the flow of the water or the stream, we call it downstream. And if the boat is going against the flow of water, then we call it as upstream. Second point in this, second point is if speed of boat in still water is u kilometer per hour and speed of stream is v kilometer per hour, then what will be the downstream and upstream speed? So in this case, let's say river is in flowing in this direction with speed v, and we have a boat which is going in this direction with speed u. So what will be the downstream speed? Speed of downstream. So in case of downstream, velocity of boat and velocity of water will be into the same direction. So we will add them. So downstream speed will be u plus v. Second case, this is flow of water, and the boat we have is going in opposite direction to it with u. Now the boat will go against the flow of the water if and only if the speed of boat is greater than flow of water. Otherwise, the boat will be in the flow of water. It will go along the water. So if you want to make it against the water, speed of the boat has to be greater than flow of the water. Speed of boat has to be greater than flow of the water. So in this case, we call it as speed upstream. Speed upstream, because they are both in opposite sense. So this will be u minus v. Understood? Are you getting it? Okay, next point is if the speed downstream is given to us, speed downstream is a kilometer per hour and speed upstream is b unit, then what will be the speed of the boat in still water? So speed in still water will be half of a plus b, and rate of stream, or you can call it as flow of river, water will be equals to half of A minus B. Understood or any doubt?
Understood,
Yes.
sir.
Okay. Next point is let's say this is a river. Speed of river is V in this direction. And there is a person, width is let's say X unit. There is a person who is wishing to cross the river. You want to go from this point to this point. So how much time will it take him to cross the river? If he can swim in still water at the speed of u km/h, the speed of man in still water is u unit km/h. So how much time it will take? So if he just jump in this direction with speed u, the river will make it flow in this direction with speed v, and it will go like this. So time taken to cross this river will be same as time taken by him to cover this distance x with the speed u, because speed v will not help him in vertical direction. Speed v will help him to go into the horizontal direction. So time taken to cross the river will be distance upon speed, that is x by u. Understood?
Yes, sir.
Next point is a man can swim directly across a stream of width x kilometer in t hours when there is no current. When there is no current. No current means there is no flow of water, water is still when there is no current. And the same man takes t hours when there is a current. So what is the rate of the current? In this case, rate of current is given by x square root of 1 upon t square minus 1 upon t dash square. This will be direct formula for the case. Okay. Now we can just solve the question. The core concept in this aptitude chapter is upstream and downstream. If we are going downstream, velocity will add or speed will add, and if we are going upstream, speed will subtract. That's the core concept. First question is the speed of a boat when traveling downstream is 32. So in question we are given with downstream speed, that is A, that is 32 km per hour. Whereas when traveling upstream it is 28. Upstream speed is B, that is 28 unit kilometer per hour. What is the speed of boat in still water and speed of the stream? So first we have to find out speed of boat in still water. So speed of boat in still water will be given by half of A plus B. So that will be half of 32 plus 28. This will be how much? 1 by 2 into 60, that is 30 unit. And if you want to know what is the speed of the stream, speed of stream will be half of 32 minus 28, that is half of 4, that is 2 unit. Understood?
Yes, sir.
Yes, sir.
Yes. कोई डाउट है?
No, sir.
No, sir.
Next question is, a man takes 3 hours and 45 minutes to row a boat 15 kilometers downstream of a river. A man takes downstream and he takes 2 hours 30 minutes to cover a distance of 5 kilometers upstream. To cover a distance of 5 kilometers upstream, find the speed of river. Find the speed of river or find the current in river. इस तरीके का क्वेश्चन भी आ सकता है. So in this case, we are given with downstream distance and downstream time. So from the information we can calculate downstream speed. Let me write it in short form. Downstream speed will be time, sorry, speed is distance by time, right? So this will be distance 15 kilometer upon time. Time is 3 hour and 45 minutes. So 3 hour and 45 minutes will be how much? In hours. 45 minutes in hours will be 45 divided by 60, 3 by 4. So this will be 3 and 3 by 4 hours. So you can write it as 15 by, this will be how much? 15 by 4, I think. So downstream speed is 4. Downstream speed is A, which is 4. Now upstream speed is distance by time again. Distance is 5 kilometers upon time is 2 hours and 30 minutes. That is 2.5 hours. So this will be 5 upon 5 by 2. So this will be 2. Hence upstream speed given by B is 2. We have to find out current in the river. So current in the river will be current in the river will be half of A minus B. That is half of 4 minus 2. Half of 2, that is 1 unit, 1 kilometer per hour. And if you want to know the speed of boat in still water, speed of boat in still water in the same question. So in that case, this will be kya? Half of A plus B. So this will be half of A is how much? A is 4 unit. Hello. These 2 unit. जी बोलो ना. किधर? अभी तो लेक्चर है मेरा 10:20 तक. हाँ हाँ ठीक है. Are you getting it? Yes. Any doubt?
No, sir.
Okay, let's try this question. Question is, a man. ये बार बार man क्यों आ रहा? A woman can row 6 kilometer per hour in still water. It takes him twice. It takes him twice as long as to row up as to row down. The river. Find the rate of stream. Find the rate of stream. How will you solve it? Try करें. A woman can row 6 kilometer per hour in still water, and it takes him twice as long as to row up as to row down the river. Which means if you are taking upstream speed as x, his downstream speed will be 2x according to the condition, because it takes double time to come upstream as compared to downstream, which simply indicates that if we are covering the same distance in upstream and downstream, then speed has to be doubled in case of downstream. Are you getting it? Yes. Are you getting, or any doubt? Okay. Now we have to find out the rate of stream. Now we know that speed in still water is given by speed in still water. Speed in still water is given by half of this is A, this is B, half of A plus B, right? So this will be half of x plus 2x, and speed in still water is given to us, that is 6. So this will be 3x is equals to 12 and x is equals to 4. Yes, which means rate upstream is, or let me write it as upstream speed is x, that is 4, and downstream speed is 2x, that is 8. So if you want to have rate of stream or rate of current of the river, so rate of stream, this is B, this is A, is given by half of a minus b. So this will be half of 8 minus 4. That is half of 4. That is 2. So answer will be 2 in this case. Understood? Understood or any doubt? बोलो भाई समझा कि नहीं समझा? Next question is a man can row 7.5 kilometer per hour in still water. If in a river running at 1.5 kilometer an hour, it takes him 50 minutes to row to a place. 50 minutes to row to a place and back. How far off is the place? How far off is the place? So how will you solve it? Yes? Okay. Let's say a stream of river is given to us. That is 1.5 kilometer an hour, which means V is 1.5 unit. And speed of the man in still water is 7.5 kilometer per hour. 7.5 kilometer per hour means how much? 7.5 kilometer per hour, right? So the value of u is 7.5, and if he's going against, that will also be 7.5. So what will be downstream speed? Downstream speed will be 1.5 plus 7.5, because in downstream both the velocity and speed will be in the same direction, will be added. So this will be how much? 9. Upstream speed will be 7.5 minus 1.5, that is 6. Now in question it is given that it will take 50 minutes to go to a place and to come back. So journey will be like this. This is the point of starting, and the person goes to certain place. This is place P, and then again come back to the original position. And in this complete journey, it will be 50 minutes, which will be taken. So this will be downstream, this will be upstream. Time taken in downstream will be what? Speed is distance by time. So time is distance by speed. Time is distance by speed. Let's say this distance is x unit. So what will be the time taken in downstream plus time taken in upstream will be equals to total time taken, that is 50 minutes. Now time taken in downstream will be distance in downstream divided by speed downstream. Speed downstream is 9 and this is given in kilometer per hour. So time will be in hours plus this will be x divided by upstream speed is 6. So this time is again in hours. On right hand side we have times in minutes, so we have to convert it into hours divided by 60. Now we can simplify it. This will be how much? This will be 6x plus 9x divided by 9 into 6 is equals to 50 by 60. 6 factor will cancel out. 1 0 will cancel out. So we are left with how much? 9 plus 6. 15x I think will be 5 into 9. This will be 45 and hence x will be 3. So the distance of the place from the point of starting is 3 kilometers. Are you getting it or any doubt? Total distance पूछी क्या? How far off is the place? Total नहीं पूछा. ओवरऑल जर्नी का डिस्टेंस नहीं पूछा, बस ये पूछा कि जहां से वो चला है, स्टार्ट किया जहां से उसने, वहां से ये देंगे कितनी दूर रही होगी. नेक्स्ट क्वेश्चन, again same question. A boat goes 8 kilometer upstream. Upstream speed is 8 kilometer per hour. One second. It's not upstream speed. Question is, a boat goes upstream 8 kilometer and the returns and then returns. Total time taken. Total time taken is 4 hours 16 minutes. If the velocity of current is 1 kilometer per hour. If the velocity of current is 1 kilometer per hour, find the actual speed of boat. Find the actual speed of boat. So how will we solve it? Question is like this. This is a river flowing at 1 kilometer per hour. And there is a boat which has certain speed. What is its speed? We do not know. Let's say its speed is x. So in this case, downstream speed will be x plus 1 and upstream speed will be x minus 1. According to question, this boat goes 8 kilometer upstream and then come back to the original location. And in this journey, 4 hours and 16 minutes is taken. What will be the speed of boat? So total time taken will be again time taken in upstream plus time taken in downstream, and that is equals to overall time is 4 hours 16 minutes. So this will be 14 and 16 by 60. 4 hours plus 16 by 60 hours. What will be time taken in upstream? So again, speed is distance by time. So time will be distance by speed. So time taken in upstream will be distance covered in upstream upon upstream speed. So distance covered in upstream is 8 kilometer and upstream speed is x minus 1 plus, in case of downstream, distance will be same because it will return to the original location, and speed is x plus 1. So this will be equals to how much? 4 4 ja, and this will be I think kitna 50. So this will be 64 by 50. Am I right? Yes or no? Cancel the factor of 8. This will be 8. This will be 1 upon x minus 1 plus 1 upon x plus 1, which is equals to 8 by 50. If you will solve it by taking LCM, this will be x minus 1 into x plus 1, which will be x plus 1 plus x minus 1 is equals to 8 by 15. So 1 will cancel out, and we are left with 2x upon x minus 1 into x plus 1 will be x square minus 1, which is 8 by 15. And if you will cross multiply, this will be how much? And this will be 8x square minus 8 is equals to 30x. On rearranging, this will be 8x square minus 30x minus 8 is equals to 0. Divide it by 2. This will be 4x square minus 15x minus 4 is equals to 0. And if you will factorize it, this will be 4x square minus 16x plus x minus 4 equals to 0. Take 4x common. This will be x minus 4 plus 1 common. X minus 4 is equals to 0. So 4x plus 1 and x minus 4 is equals to 0. So x either will be minus 1 by 4, this will be plus 4. Because x is taken as speed and speed cannot be negative. So correct answer will be 4. Understood? Correct answer will be what? 4 units. Any doubt in it? क्या डेट है आज 9। पीडीएफ भेज रहा हूँ भाई, ये डाउनलोड कर लेना। देखो पीडीएफ सेंड किया, डाउनलोड कर लो।
Yes, sir.
कर लिया डाउनलोड?
Yes, sir.
Yes, sir.